All right, let's jump right in. Today, we're going to pull back the curtain on how automated systems make those split-second smart decisions. We're talking about the language they speak, and more importantly, the grammar that actually gives that language its power. Let's see how it all clicks together. I mean, really think about that for a second. When these things happen, there's no person in a back room scrambling to check a bunch of boxes. Nope. There's a system, and it's a wicked fast one that has to understand a whole mess of conditions and act on them right away. So the real question is, how on earth does it know what to do? Well, the secret is all about a set of really carefully written rules. And these rules, they're written in a special language that's designed to be understood by both the business experts and the computer systems. So first, let's just properly frame the problem we're solving. We're talking about the massive challenge of getting consistency, but at a huge scale, making the exact right call every single time, thousands of times a minute. And the solution is found by, you guessed it, speaking the language of rules. It's all about teaching this system our business logic, not the other way around. And that language is BAL, which stands for Business Action Language. Now, what's so cool about this is how it was designed. It's meant to be super readable, looking almost like a plain English sentence. This means the people who actually know the business rules inside and out, the loan officers, the marketing managers, they can read, understand, and even help write the logic that runs their part of the business. But just like any language, just having a bunch of words isn't enough. You need grammar to connect those words and form sentences that actually mean something. In the world of BAL, that grammar is all powered by things called operators. Think of them as the crucial building blocks that let us compare things, link ideas together, and ultimately take action. So let's open up this operator toolkit. This is the essential grammar we need to build our rules. First up, we've got the most fundamental of them all, comparison operators. These are your bread and butter for asking basic questions. Is this thing equal to that thing? Is this number bigger than another one? They're super intuitive, using phrases you already use every day, like is equal to and is greater than. This is pretty much the starting point for almost every rule you can imagine. And this example shows it perfectly. It's a simple, crystal clear statement. The operator here is greater than. It just checks a fact about the customer. And if that condition turns out to be true, it triggers an action. It's that direct. If this, then that. But life's rarely that simple, right? What if one condition just isn't enough? Well, that's where logical operators come into play. These are the conjunctions, your ands, ors, and nots, that let us chain multiple comparisons together to create way more nuanced logic. They let you say, hey, this and that have to be true, or maybe just one of these is good enough. Okay, let's look at this one. Here we're using two operators at once. The and connects two totally separate checks. First, is the customer active? And second, is the customer not blocked? Only if both of those conditions are met does the transaction get the green light. You can see how we're starting to build in safeguards and more complex criteria. Of course, business rules are often about numbers and doing a little math. So naturally, we have arithmetic operators. These are exactly what you think they are: plus, minus, multiply, divide. They let you perform calculations right inside your rules, whether you're figuring out a final total, calculating a bonus, or determining some kind of ratio. And here is a perfect everyday example of that. To get the final price, you take the base price, you add the tax, and then you subtract the discount. It's simple, it's clear, and it's exactly how you'd explain it to another person. The system just does the math for you. Now, things start to get really powerful when we're dealing with groups of things, or what we call collections. Think about all the items in a shopping cart, or a customer's entire order history. Collection operators let us work with these lists. We can check if a cart contains a specific item, if a shopping list is empty, or check the size of the list to see just how many items are in there. So after all our checking and comparing and calculating, we have to actually do something. That is the job of the assignment operators. These are the action words. They set a value, like a discount. They add an item to a list, like a product to a cart. They are the verbs that actually make changes to the data. Okay, so we've seen all the individual tools. Now, let's actually build something. We're going to combine a bunch of these operators to create a pretty sophisticated rule, step by step. We always start with when. That just signals to the system, hey, here come the conditions for my rule. And our first condition is super simple, just a basic check. Is the customer active? All right, next we're going to add a second condition using our logical operator and. We're also using the collection operator is not empty to make sure this customer has actually bought something from us before. We don't want to run this rule on customers with no order history. And now for our final condition. We'll tack on one more and, but this time we're combining two operators. Size of to count the orders, and is greater than to check if that number is more than 3. So our completed condition now specifically targets active customers who have more than 3 past orders. So now that our when conditions are all set, we define the then block. This is the action part. Here, we're using for each to loop through every single order in that customer's history. And inside that loop, we have another if statement, this one checking if any of those orders had a total greater than 500. And there it is, the complete rule. If our system finds even one order over $500, we trigger 2 actions using our assignment operators. We add a VIP tag to the customer's profile, and we set their loyalty level to gold. I mean, look at that. In just a few readable lines, we've built a really powerful rule that automatically finds high-value customers and gives them an upgrade. So after going through all that grammar, let's zoom back out. Why does any of this really matter? What's the big takeaway? It's because these operators, as simple as they seem on their own, are the essential bridge. They allow a business to take all of its nuanced, complex human knowledge, all those if this happens, but only if that is also true scenarios, and translate it all into clear, unambiguous instructions that a machine can execute flawlessly millions of times over. They turn logic into action. And that leaves us with a fun little thought experiment. These rules govern everything from tiny discounts to massive financial decisions. So if you could write just one rule for the world to follow, what would its logic be? Thanks for digging into this with me.